So children, today we will see the next very important part in the second chapter, that is acids, bases and salts. Now here we have to see today about the properties of acids, bases and salts. Acids, bases and salts. So children, first I am going to explain about the acids. So acids are able to provide the hydrogen ions, and so hydrogen ions, they are neutralized by hydroxyl ions. So when we mix an acid and a base, there is the formation of salt and water. So children, you have to keep in mind. So here neutralization reaction. Neutralization reaction. So acid and base, when react together, there is formation of salt and water, and this is nothing but this is called as neutralization reaction. And so neutralization reaction is equally responded. It is equally responded by acids and bases. So here acid, here base, salt and water. So any acid and any base can react together. Say acid, I am taking weak acid, Cl3COOH. This is acetic acid. This is acetic acid. And if we take base, let it be calcium hydroxide. It is calcium hydroxide. So there is reaction and there is the formation of this is calcium acetate plus H2. This is also neutralization reaction, children. We can have the weak acid, weak base, a strong acid, a strong base. So children, this is the first condition, that is the neutralization reaction. Now children, other is displacement reaction. Displacement reactions. So children, acids, they undergo displacement reaction. They displaces hydrogen in the reaction. See how? If you take zinc and HCl, here we take the aqueous. So zinc is more reactive, and so HCl having the hydrogen is displaced, and there is ZnCl2 plus there is hydrogen. If you want to balance it, so we'll have this. So hydrogen gas is released, and here there is formation of the aqueous zinc chloride. This is zinc chloride. This is called as displacement reaction, children. This is called as displacement reaction, and in displacement reaction there is the displacement of the hydrogen by the this metal. We can take the aluminium plus HCl. There is formation of AlCl3 plus there is the hydrogen. This is aluminium chloride. And so here you have to balance it, and so ultimately balancing will be there. So here hydrogen 2, here hydrogen 3. So 3 is not the coefficient. So you have to bring here, and in such condition the balancing is very much important. And so children, here 2, here 3. So some points has to be taken into consideration. So 3 here, and so we place here this one, and so 6 and 2, and so here it is 2. So this is, I have tried to balance. How you balance? So balancing is possible when we take care and we have some practice. Practicing is important, and so we have to take care, and we have then this capacity to balance, and we are able to get the desired result. Now children, in other conditions, see here, if you take some other metal, like here I am taking the gold and HCl. So here there will be no reaction. HNO3 and this, there will be no reaction. Gold and silver, they are inert metals. They do not react with the acids, normal acids, because they are highly stable. And so they are able to not undergo some change. Similarly, if you take nitric acid or sulfuric acid, children, so here if you take the zinc and HNO3, so there is formation of zinc nitrate plus there is H2O, and here children there is NO2 gas. This is an important point. Now I am writing other point, that is aluminium plus sulfuric acid. There is the formation of aluminium sulfate plus H2O plus SO2. Now children, nitric acid and sulfuric acid, they are oxidizing in nature. They are oxidizing in nature, and they cause oxidation of others. And children, you know, this is the point associated with oxidizing agents. They oxidize others and they themselves are reduced. So here there is the formation of zinc nitrate. So they oxidize the hydrogen. Hydrogen is converted into water. This children with HNO3 and sulfuric acid, and here they are able to lose the hydrogen, and so there is formation of NO2 and there is formation of SO2. And children, this is very much important to note that the nitric and sulfuric acid, they oxidize others and they themselves are reduced. So this is children about the acids. Now children, I am coming to the bases. So children, bases are also able to do some reactions, and in case of bases, again there is the neutralization reaction, just like acid. So neutralization reaction is also responded by bases. So here we take the H2SO4, here we take the KOH, and there is K2SO4 plus H2. This is potassium sulfate. This is potassium hydroxide. This is sulfuric acid. So neutralization reaction. Then children, they also respond this displacement reaction. Displacement reaction is also responded, but the displacement reaction is not as significant like the acids, and displacement reaction with the bases is very much limited. Very few. Only the reactive metals can undergo displacement reaction. If you take the zinc or aluminium, they undergo displacement reaction. So if you take the aluminium plus NaOH aqueous, there is formation of this is sodium aluminate. So here also there is the liberation of hydrogen by reaction between reactive metals. Children, reactive metals like zinc, aluminium, magnesium, they undergo these reactions, but the intensity of reaction is very less. Here you have to keep in mind the intensity of reactions are much less. They are much less than acids. It is due to the nature. It is due to the nature of the acid. Children. So children, this is about the very important part, that is about the acid, base and salt. And so bases they undergo neutralization reaction, and so neutralization reaction just like the acids, and here there is the formation of salt and water just like their response. So sulfuric acid, KOH, potassium sulfate, water. So this is sulfuric acid, this is potassium hydroxide, KOH, potassium sulfate, water. This is neutralization. So this neutralization reaction is at par with an acid. Similarly, they undergo displacement reaction also. So displacement reaction by the bases is responded by only reactive metals like zinc, aluminium, etc. Similarly, children, if I take aluminium, sodium hydroxide, when we take aluminium or put aluminium in sodium hydroxide or potassium hydroxide, a strong base has to be taken. This reaction cannot take place by the weak bases, and the metal must be reactive. So there is formation of sodium aluminate. Sodium aluminate is formed. Sodium aluminate is formed by reaction and hydrogen gas is liberated. So children, this is at par. It is very much in accordance with the acids. And so this is about the bases, about the reaction of the bases. Now children, I am going to explain about the few points of the salts. So children, salts are neutral substances. Salts are neutral substances and they are quite stable. Salts are neutral substances and they are quite stable, and they do not undergo any reaction with bases in normal conditions. These salts react only under very specific conditions. Like the acids must be very strong acids must be taken because of the nature of the salts. And we have different salts, already we have acidic salt, we have basic salt, we have neutral salt. So different categories of salts undergo different state in a different manner. Like if you take the NaCl, so NaCl can react with concentrated sulfuric acid, and we have to heat it. Just I am saying you have to keep in mind that sodium chloride is salt. It is decomposed. There is decomposition by sulfuric acid concentrated only by heating, and there is formation of N2SO4, and here there is formation of H2O, and here there is formation of chlorine gas. So children, you have to keep in mind here this is salt. Hydrogen has been converted to water, and instead there is release of the chlorine. So this is very much important part. And the salts, they are not respondent. If we take NaCl and here we take acetic acid. Acetic acid is a very weak acid, so there will be no reaction. No reaction will be there, and so this you have to keep in mind. Reactions takes place under proper conditions. Now children, other point in this I am going to write here, that if you take any other salt like Na2CO3, this is sodium carbonate, and here if you take the weak acid, this is acetic acid. So acetic acid will decompose the sodium carbonate, and there is formation of this sodium acetate plus CO2 is released along with the water. So children, here this I have written because CO2 gas in any reaction, it has a specific feature, it has a specific property, and CO2 gas is released with brisk effervescence. Brisk effervescence. Brisk means very fast. Brisk means fast. Like we say walk briskly. Walking. So walking can have different dimensions. It can be fast walking. It is called a brisk walking. Slow walking. When we fast very much, then it becomes running. So this you have to know. So brisk, very fast, and effervescence. Effervescence means some sound which is unclear. So children have to keep in mind that whenever CO2 is released in any reaction, it is called as brisk effervescence. It is fixed. It is fixed for any reaction, and so it is the condition, and so we have to take into mind. This is very important point. Brisk effervescence. Brisk effervescence means the sound which is coming very fast and it is unclear. I am citing a very important example. You all open cold drink bottles. So what happens? When we open cold drink bottles, then very suddenly the gas comes out very fast, but the sound is just hissing. Sound is not clear. Response is very fast, but the sound is not clear. So such type of condition is called as brisk effervescence. And children, all the gases they have a specific feature. All the gases have a specific feature. Like this word brisk effervescence, it is exclusively fixed for carbon dioxide. Similarly, like NO2, children, NO2 gas, in any reaction, if it is NO2, then NO2 it has brown color and pungent smell. Like see, if we take copper and if we take HNO3, copper HNO3, NO2, then copper nitrate, then H2. So this is the point that NO2 has. Similarly, if you take Fe, iron, if you take sulfuric acid, then there is summation of SO2, sulfur dioxide, and FeSO4, and here there is water. So this sulfur dioxide, children, it is colorless. It is colorless with a smell like that of firecrackers. So this is the way how we are able to identify any gas during reaction. So children have to keep in mind CO2 brisk effervescence, very fast, NO2 brown color and pungent smell, SO2 colorless with smell like that of burning of firecrackers or burning of matchstick. Because matchstick, firecrackers, they have sulfur. Whenever sulfur burns, there is formation of SO2 and SO2C. So this is very much important point to note. Now children, one point efflorescence. Efflorescence is the property of some salts by virtue of which they lose water molecules on their own. So it is the loss of water molecules, by the substance, on its own at normal state or normal condition. If we take salt, children, Na2CO3 10S2, this is washing soda. So when washing soda is exposed, or it is unattended, or it is not kept safely, then it loses water molecules on its own, and this is called as efflorescence. This is nothing but this is called as efflorescence. The loss of moisture present. See the tin water molecules, they are present in sodium carbonate. It is called as sodium carbonate decahydrate, and so it loses water molecules. So this is at normal condition, that is at the room temperature, and so this is nothing but this is called as efflorescence. So next part in general acid bases is the dissolution. Dissolution or dissolving acids and bases. So dissolution of acids and bases is very important point, very important property of acids and bases, and there are many examples, like when you can take the base like calcium oxide, quicklime. Children, you all must have seen during the whitewashing at our homes, we bring the quicklime, we bring the chuna or kali chuna for whitewashing. When we add water, what happens? There is the boiling of the water. The water present in the vessel starts boiling on its own, and there is formation of calcium hydroxide plus large amount of heat, and as a result, this is calcium hydroxide, this is slaked lime. So children, there is the liberation of excess amount of heat, and you might have seen at your homes or nearby places the water in the vessel in which kali chuna or lime or quicklime it has been kept. It starts boiling, and if the vessel is weak, then it may cause damage to us. So we take the proper care. This is quicklime. Calcium oxide is called quicklime. Why? Because it reacts with water very quickly to form the slaked lime. This is very simple. Again I am repeating, why calcium oxide is called quicklime? Because calcium oxide very quickly reacts with water to form the slaked lime. Again, what is slaked lime? So slaked lime is a lime which is obtained by slacking. Slacking means to settle down. So you must have seen after doing this process, the water settle down in this along with this chuna or this slaked lime, and so this is point. Now children, about the acids also. When we add any acid into water, we get the aqueous solution. Of acid, and plus large amount of heat is liberated. And this is because of the heat of hydration. Because heat of hydration, of acids is very high. So heat of hydration means when 1 mole of an acid or 1 mole of a substance takes up water molecules during the formation of aqueous solution. So that is called as heat of hydration. Once again I am repeating, heat of hydration is the amount of heat liberated when 1 mole of a substance is dissolved into water. So heat of hydration is very important aspect, and so children, care must be taken during the preparation of dilute solution. So care must be taken to add little amount of acids to water with little amount, with constant stirring. And so what will happen? As we are adding in a small amount with constant stirring, so what will be there? The heat produced during the dissolution will be dissipated, means it will be given out. And so this is very important point, and we never add water to acid. Why? Because suddenly very large amount of heat is liberated, children. Suddenly very large amount of heat is liberated, and it will cause damage. It will bump out, as may damage the vessel, may jump out. And so this is very important point in this acids, bases and salts. So children, this is all.